Hello everyone, welcome back to Rebar 360. In today's US rebar detailing concepts video, we're going to answer a question that confuses many beginners and even some experienced detailers. Where should we use top bar lap? When you look at structural drawings, you'll often notice two different lap lengths, one for top bars and another for other bars. Many people simply memorize these values without understanding the reason behind them. In this video, I'll explain what a top bar actually is, why it requires a longer lap, where it should be used, and where it should not be used. Once you understand the concept, you'll never be confused by lap schedules again. Let's get started. Let's begin with the basic question. Why do we have two different lap lengths? The answer lies in the quality of the bond between concrete and reinforcement. When fresh concrete is poured, water and trapped air naturally move upward. This process is called concrete bleeding. If a reinforcing bar is located near the top of a deep concrete pour, small voids can form underneath the bar. These tiny gaps reduce the bond between the concrete and the steel. Since the bond is slightly weaker, ACI requires a longer lap length to safely transfer the forces from one bar to another. On the other hand, bars that don't experience this condition can use the standard lap length because the concrete surrounds them more effectively. So, the longer lap is not because the steel is different. It's because the bonding condition is different. Now let's define what ACI considers a top bar. A top bar is not simply a bar placed at the top of a member. This is a common misunderstanding. According to ACI, a top bar is a horizontal reinforcing bar that has more than 12 inches, or 300 millimeters, of fresh concrete cast below it. The important part is the depth of concrete below the bar. Imagine you're pouring a thick raft foundation. If the top reinforcement has more than 12 inches of concrete beneath it during the pour, it becomes a top bar. But if you're working with a thin slab that has only 6 inches of concrete below the top steel, it is not classified as a top bar, even though the reinforcement is located at the top of the slab. So always remember, the classification depends on the concrete depth below the bar, not simply its position. Here's a simple 3-step method that you can use on any project. First, ask yourself: is the reinforcement horizontal? If the answer is no, then it's not a top bar. Next, check the concrete depth below that bar. Is there more than 12 inches of fresh concrete beneath it during casting? If the answer is no, then use the other bar lap. If the answer is yes, then the bar qualifies as a top bar, and you should use the top bar lap specified in the structural drawings. Whenever you're unsure, just go through these 3 questions. It's a quick and reliable way to avoid mistakes. Now let's see where we normally encounter top bars in real projects. The first example is a raft foundation. Large mat foundations are usually quite thick, so the top layer of reinforcement often has more than 12 inches of concrete below it. In this case, the top reinforcement is considered a top bar. The second example is deep beams or thick slabs. If the top longitudinal bars have more than 12 inches of concrete beneath them, they also require top bar lap. The third example is horizontal reinforcement in walls. If the wall is poured from the bottom upward and a horizontal bar has more than 12 inches of fresh concrete below it, that bar also qualifies as a top bar. These are the situations you'll commonly see in US detailing projects. Now let's look at where top bar lap should not be used. Column vertical bars are not top bars because they are vertical. Concrete flows around them differently, so the bond reduction caused by bleeding doesn't apply in the same way. The same applies to vertical reinforcement in walls. Beams, stirrups and ties are also excluded because they are transverse reinforcement, not the main horizontal flexural bars. Finally, bottom reinforcement in slabs or foundations is not considered top bar reinforcement because there isn't enough concrete below those bars during casting. Understanding where not to use top bar lap is just as important as knowing where to use it. This is a very important point for every rebar detailer. Even though ACI provides general rules, every project has its own specifications. Some clients prefer to use top bar lap for all top reinforcement, regardless of the concrete depth. Why? Sometimes they want a conservative design or they follow company standards that go beyond the minimum ACI requirements. As detailers, our responsibility is to read the structural notes carefully before preparing the shop drawings. If the project specification differs from the general code, always follow the project requirements. Never assume. Always verify. Let's discuss a few mistakes that are very common among beginners. The first mistake is applying top bar lap to every top reinforcement layer. This increases steel quantity unnecessarily and can lead to higher project costs. The second mistake is ignoring the orientation of the bar. Remember, top bars are horizontal bars. Vertical bars are not classified as top bars. Another mistake is forgetting to check the concrete depth below the reinforcement. Many people only look at the drawing without thinking about how the concrete is actually poured. Finally, some detailers skip the structural notes and directly use the standard lap schedule. Always review the project notes before making detailing decisions. These simple checks can save a lot of revisions later. Let's quickly review today's concept. A top bar must be a horizontal reinforcing bar. It must have more than 12 inches, or 300 millimeters, of fresh concrete cast below it. Because of concrete bleeding, the bond between steel and concrete is slightly reduced. That's why a longer lap length is required. And finally, before applying any lap length, always check the project specifications and structural notes. If you remember these 4 points, you'll be able to identify top bars confidently on any project. I'd like to leave you with one important message. Don't just memorize the lap length table. Instead, understand why the code requires a different lap length. When you understand the engineering reason behind the rule, you won't have to depend on memory. You'll be able to analyze any situation and make the correct detailing decision. That's what separates a professional rebar detailer from someone who simply copies information. Always focus on understanding the concept, not just the numbers. Thank you for watching this video. I hope this explanation helped you understand where top bar lap should be used and, more importantly, why ACI makes this distinction. If you found this video useful, please support Rebar 360 by liking the video, sharing it with your colleagues, and subscribing to the channel. Also, let me know in the comments if you've ever come across a project where the client specified top bar lap differently from the standard ACI practice. I'd love to hear about your experience. I'll see you in the next video with another practical concept from the US Rebar Detailing Concept Series. Thank you, and happy detailing.